And finally, we come to the third transformational concept of material that comes out of toy physics. And that's of primal expansion, which drives all behavior. You see in that web a depiction of a radial element, that black element coming up from the center. That's the spinal body of an atom, that radial element. You've seen it before, I think, but R space, that symbol, just stands for relation space. So these are R space universes, and this is the one with just one pointing dimension. It's a one-dimensional universe as far as motion. And it has a radial spinal body. All of them do, this one and the higher dimensional ones. That radial spinal body expands outward from the center at the speed of light. So we just calibrate it to say that it expands at our speed of light that we experience and measure. And that outward expansion causes an influx of primal substance. It's like a flux called R flux. And it's very, that's primal material, primal substance. And that influx has that form of Einstein's energy equation, m times the speed of light squared. In toy physics, this is very rigorous. We're just depicting a little picture here that illustrates it. And that influx is a flow of energy that is allocated for different purposes. It supports web growth. This is an expanding web. As the primal expansion goes, then so does the entire web. The sensory distances increase in the web. So it supports web growth, and it supports participation in collective behavior with other atoms. And it propels motion and compression. So the energy that we see in modern physics, the poppers don't see it in the same way we do. We have the same equations and the same behavior, but to poppers, energy flows into each atom from primal expansion, and it flows outward in the sensory directions to be a carrier for the things that we call fields, like light and gravity and so forth. Of course, it's this is a very simplistic depiction, and really the toy physics universes and atoms are very simple compared to real atoms, but the behavior, as we've said before, is astonishingly well aligned. The mathematics of a dynamic web like this with an inner dimension of behavior that it expands is not the same mathematics as in actual physics. It's a variation. It's a variation, for one thing, of the Pythagorean, utilization of the Pythagorean theorem. It's a variation of the ideas of Descartes with his Cartesian coordinates. And so with this, we've introduced the third transformational concept. And so we have all three now. The first one being the physical relation concept of participants joined in collective behavior. Then the second one was the inner concept of embodied inner dimension of depth participating in the outer expanse. And this third one is the concept of primal expansion that drives all behavior and causes distances in the universe to expand. The final slide, 130, just points to the next video, which will give graphic demonstrations of some of the mechanics. And the mathematics here is really depicted as mechanics through props. So we'll see the mechanics of web growth through radial primal expansion. And so we'll see the mechanics of Pythagorean resource allocation, which is the alternative interpretation of the Pythagorean theorem that is so vital in rigorously defining an inner dimension that is not a pointing sensory dimension.